Today we're studying integration by parts. What integration by parts allows us to do is integrate a very wide range of functions. Right now we're kind of limited to some formulas that we know. And by studying this, we're going to expand the list of functions we can take, or the list of functions we can take the integral of. So we need to find integrals using the technique integration by parts. We're going to identify the correct u's and dv's of an integrand, and you got to set up and use the tabular method for integration by parts. Now the tabular method is not tested on your AP exam, but you are allowed to use it, and it's going to save you a lot of time if you know what you're doing. So the integration by parts is derived from the product rule, and it's just the product rule worked backwards. If we look at a product of u times v, and we want to take this derivative, d dx. This is going to be, leave the first one alone, take the derivative of the second, add to that, leave the second one alone, take the derivative of the first, the u dx. Now what we're going to do is we're just going to do some manipulation here. I'm going to multiply each side of my equation by dx. So this, and this are going to reduce. We'll be left with the d of u times v is equal to u dv plus v du. Now we're going to take the integral of both sides. And the integral of duv is just uv is equal to the integral of u dv plus the integral of v du. And so what we'll do is we'll solve for this integral right here by subtracting the integral of v du from both sides. And you've just derived the integration by parts formula, which says that the integral of u dv is equal to uv minus the integral of v du. What we'll have to do is, when you're doing this, you have to identify the correct u and dv of an integrand, and that's going to help you fill in your formula here, but we need to memorize this here. The integral of u dv is equal to uv minus the integral of v du. You could derive it every time, but that's going to take a while. So let's look at the integral of the natural log of x dx. This is something we can't take an integral of. We've been able to do some definite integrals of natural log of x, but that's only because we've had a calculator. Now we're going to do the indefinite integral, and what we need to do is we're going to let u, in this case, be just this part right here, the natural log of x. And we're going to let dv be whatever's left over. And the only thing left over in this case is your dx. And so we're going to continue this table now, okay? You want to figure out who du is, the derivative of u. Well, the derivative of u is 1 over x dx. And then you want to figure out who v is. And to get from v, you take the integral of dv. And the integral of dx is just x. So I like to write down my integration by parts formula every single time because it helps me memorize. And so I'm going to write it right here. The integral of u dv is uv minus the integral of v du. And so down here we'll say integral of the natural log of x dx. The integral of uv is, or u dv rather, is. Now our u and v, I look to my table. U is the natural log of x. V is x, I'm going to write my x in front, minus the integral of v, which is x, du, which is 1 over x dx. Now x times 1 over x dx is just going to be 1 dx. The x times the 1 over x reduces to 1. And this is an integral now that I can do, and that's what integration by parts is about. You're going to rewrite it into something, a product, and then an easier integral. And so this is equal to x times the natural log of x minus the integral of 1 is x, and then plus c. This is sometimes helpful for us to know. It's almost another formula for us to memorize now. The integral of the natural log of x is x natural log of x minus x plus c. Now, the hard part is figuring out who do I let u equal, who do I let dv equal. First of all, you should know that the dx always goes with the dv. Okay? Dx never goes into your u. Because remember, you're going to be integrating dv, so you need a dx there to integrate. The u you want to make the hardest part of your integral, and there's a quick little mnemonic device to help us memorize who u is, and it goes ilate, I-L-A-T-E. If you see an inverse trig function, that is the first thing you let u be. If there is no inverse trig function, then it would be a logarithmic function. There is no logarithmic function, then u is an arithmetic function. If there is no arithmetic function, u is a trigonometric function. And lastly, on this order, you would let u be an exponential function.